Every engine review talks about horsepower and torque figures, but none mention the brutal truth about long-term reliability. What if I told you that your dream V6 will strand you on the roadside faster than any racing accident ever could? That's not dramatic. Poor engineering kills more engines than abuse ever does. Imagine finally buying that truck you've wanted for years, only to discover that every breakdown feels like financial torture. In this video, I'm breaking down the 13 most reliable V6 engines that won't leave you stranded in 2025. And trust me, the #1 choice will blow your mind. It's so well engineered that owners regularly hit 300,000 miles without major repairs. Watch every second, because this isn't just a review. It's the difference between loving your truck for life or becoming another casualty of poor automotive engineering. When we talk about reliable V6 engines, we're looking at power plants that combine proven engineering with real-world durability. These engines represent the sweet spot between performance and dependability, offering the power you need without the complexity that destroys modern engines. Number 13, Ford F-150 EcoBoost V6, 2020 to 2025. Starting our countdown at number 13 is the Ford F-150 EcoBoost V6 lineup. While these engines offer impressive performance, they've faced reliability challenges that keep them from ranking higher. The 2023 F-150 received an average quality score of 78 out of 100 from J.D. Power. The EcoBoost V6 engines, including the 3.5-liter and PowerBoost hybrid variants, demonstrate the turbocharged trade-off. While they deliver excellent power and fuel economy, the intense heat and stress from forced induction create reliability concerns, particularly with turbos and cam phasers. The PowerBoost hybrid variant has been identified as a big concern by Consumer Reports, which took the unusual step of breaking it out from the regular F-150 lineup due to poor reliability. This highlights how adding hybrid complexity to turbocharged engines multiplies potential failure points. Common issues include problems with the 10-speed transmission that's been dogged with issues despite refinements. Engine concerns focus on turbo reliability and cam phaser problems. The 5.0-liter Coyote engine has known oil consumption issues affecting long-term durability. Multiple recalls have affected these engines, including oil leaks that pose fire risks and coolant hoses contacting wiring harnesses that can lead to stalling. Number 12. Toyota Tundra Twin-Turbo V6, 2022 to 2025. The Toyota Tundra takes number 12, representing one of automotive history's most shocking reliability reversals. The 2025 Tundra scored 82 out of 100 for quality from J.D. Power, but Consumer Reports now lists it as the least reliable truck, destroying Toyota's gold standard reputation. The new 3.4-liter twin-turbo V6 and iForce Max hybrid variants replace Toyota's proven V8 engines in the complete 2022 redesign. This transition demonstrates how even reliable manufacturers can stumble when introducing complex new technology. A massive recall affected approximately 280,000 vehicles for engine failure caused by machining debris. When metal shavings destroy your engine internals, your truck becomes worthless scrap with monthly payments still due. Transmission problems include parts failing to immediately disengage when shifted to neutral, potentially causing dangerous forward creeping. In-car electronics issues plague owners with problems affecting cameras, audio systems, GPS, and phone connectivity. The Tundra's failure warns that brand reputation provides no guarantee of current quality. Toyota built their reputation on bulletproof reliability, but pressure to modernize led to compromises that betrayed decades of consumer trust. Number 11, Chevrolet Colorado and GMC Canyon V6, 2020 to 2025. The Chevrolet Colorado and GMC Canyon V6 engines take number 11, representing GM's midsize truck reliability struggles. Both models appeared on Consumer Reports' least reliable vehicle list for 2021. Despite the 2025 Colorado achieving an overall J.D. Power score of 82 out of 100. These trucks were available with a 3.6-liter V6 in older models, while newer versions feature a 2.7-liter TurboMax 4-cylinder. The transition away from the V6 suggests even GM recognized reliability issues with their approach. Many problems mirror issues found in GM's full-size trucks, indicating platform-wide problems with shared components and engineering approaches. When fundamental design flaws affect multiple model lines, it reveals systematic quality control failures. Common complaints include AC blower malfunctions, worn valve seats causing engine misfires, and fuel level sensor failures. Transmission issues include jerking, shuddering, delayed acceleration, and hesitation during shifting. Electrical system failures encompass backup camera malfunctions, infotainment glitches with screens going blank, and automatic braking system defects. Multiple recalls have addressed seatbelt bolts, fuel leaks, and automatic emergency braking engaging unexpectedly. Number 10, Jeep Gladiator 3.6-liter V6, 2020 to 2025. The Jeep Gladiator 3.6-liter Pentastar V6 takes number 10. While this engine has proven relatively robust, the vehicle's specialized off-road design creates reliability challenges for daily driving. The 2021 Gladiator achieved a great overall score of 83 out of 100 from J.D. Power. The Pentastar V6 engine is fundamentally sound, but the Gladiator's compromises for extreme off-road capability introduce reliability issues for typical consumer use. The solid front axle design enables incredible articulation off-road, but creates problems like death wobble at highway speeds. Death wobble is violent shaking of the front wheels triggered at high speeds, making the vehicle difficult and dangerous to control. This isn't an engine problem, but it affects the entire ownership experience. Transmission issues frequently plague the Gladiator, including rough shifting, slipping, failure to engage gears properly, and unexpected shifts into neutral. Electrical problems affect instrument panels with malfunctioning displays and engine warning lights. Notable recalls include instrument panel cluster failures, where internal short circuits cause displays to go blank. The Gladiator demonstrates how a reliable engine can be compromised by vehicle-specific design choices that prioritize extreme capability over daily reliability. Number 9, Ram 1500 Hurricane i6, 2025. The Ram 1500's new 3.0-liter Hurricane inline-6 twin turbocharged engine takes number 9, but early reports suggest this modern power plant may face typical new generation teething problems. The 2025 Ram 1500 received a great quality score of 89 out of 100 from J.D. Power, but this rating is likely based on previous model year data. The Hurricane engine represents Ram's answer to emissions regulations and fuel economy demands, replacing the proven 5.7-liter Hemi V8. While the inline-6 configuration offers theoretical balance advantages, the twin-turbo setup introduces complexity affecting long-term reliability. Early reports from owner forums indicate issues with melted catalytic converters, particularly in high-performance RHO trim applications. This demonstrates the turbocharged trade-off, where pursuit of power creates intense heat that stresses emissions components. The inline-6 design should provide better balance than V6 configurations, but the twin-turbo setup introduces potential failure points, including turbocharger reliability, intercooling systems, and complex engine management software. Recent recalls have addressed electronic stability control system failures and headlight module software issues. The Hurricane engine's true reliability picture won't emerge until owners accumulate significant mileage. Number 8, Ford F-150 PowerBoost Hybrid V6, 2021 to 2025. The Ford F-150 PowerBoost Hybrid V6 takes number 8, representing the complexity trap affecting modern hybrid powertrains. Consumer reports identified PowerBoost reliability as a big concern, separating it from the regular F-150 lineup due to poor reliability. The PowerBoost combines a 3.5-liter EcoBoost V6 with electric motor assistance and battery pack, creating multiple potential failure points. While the hybrid setup delivers impressive fuel economy and torque, added complexity significantly impacts long-term reliability. Hybrid systems introduce battery management complexity, electric motor integration challenges, and sophisticated control software that must coordinate between gasoline and electric power. When any component fails, the entire system can become compromised. The underlying EcoBoost V6 already faces reliability challenges with turbochargers and direct injection. Adding hybrid complexity multiplies these concerns with additional electrical components, cooling systems, and software integration points. Common hybrid-specific issues include battery pack degradation, electric motor failures, inverter problems, and charging system malfunctions. These failures often require expensive dealer-only diagnostics and repairs. Number 7. Toyota Tacoma 2.4-liter turbo, i4, 2024 to 2025. The Toyota Tacoma's new 2.4-liter turbocharged i-Force 4-cylinder takes number 7, representing Toyota's departure from proven V6 reliability. The 2025 Tacoma achieved an overall J.D. Power score of 82 out of 100, but its quality score dropped to average at 79 out of 100. Consumer Reports notes that despite topping J.D. Power studies, the Tacoma's latest reliability ratings have taken a nosedive. This demonstrates how even Toyota faces challenges when introducing new complex powertrains. The transition from proven naturally aspirated V6 to new turbocharged 4-cylinder and hybrid systems introduces teething problems common with redesigned models. The shift represents industry-wide pressure to meet fuel economy standards through forced induction. Owner complaints include transmission issues such as rough or delayed shifting, hesitation during acceleration, and frequent gear hunting. Engine concerns include turbo lag, inconsistent throttle response, excessive noise and vibrations. Electrical system issues plague owners with persistent dashboard warning lights, infotainment problems including system reboots and Bluetooth disconnections, and premature battery failure. Here's where smart buyers need to subscribe to channels like this one to stay informed about which engines to trust and which ones to avoid. We analyze real-world reliability data so you don't learn these lessons through expensive breakdowns. Number 6. Ram 1500 3.6-liter Pentastar V6 with eTorque, 2020 to 2024. The Ram 1500's 3.6-liter Pentastar V6 with eTorque mild hybrid system takes number 6, representing a significant turnaround in Ram's reliability reputation. The 2025 Ram 1500 received a great quality rating of 89 out of 100 from J.D. Power, and the 2021 model tied with Toyota Tundra as most reliable truck. The Pentastar V6 with eTorque demonstrates how mild hybrid systems can improve efficiency without severely compromising reliability. Unlike full hybrid systems, the 48-volt eTorque setup primarily assists the gasoline engine for efficiency and torque, rather than providing electric-only capability. The eTorque system uses a belt-driven motor generator that provides smooth start-stop operation and additional torque assistance during acceleration. This simpler approach avoids full hybrid complexity while delivering meaningful fuel economy improvements. The Pentastar V6 has proven robust across multiple Chrysler applications. With a track record spanning over a decade of production, the engine's port and direct injection combination provides good power delivery while avoiding carbon buildup issues. However, the Ram 1500 platform still faces challenges with air suspension systems, electronics, and infotainment problems affecting overall ownership experience. Recent recalls have addressed various electrical fuel, brake, and steering systems. The eTorque Pentastar represents a balanced approach to modern efficiency requirements without the extreme complexity that destroys reliability in full hybrid systems. Number 5. Jeep Gladiator 3.6-liter Pentastar V6 engine core, 2020 to 2025. The Jeep Gladiator's 3.6-liter Pentastar V6 engine core takes number 5 when evaluated purely as a power plant, separate from vehicle-specific reliability issues. The Pentastar V6 has proven itself across numerous Chrysler applications with a solid track record. The Pentastar engine features modern aluminum block and head construction with dual overhead camshafts and variable valve timing. The design incorporates lessons learned from decades of V6 development, avoiding complexity pitfalls that plague newer turbocharged engines. The naturally aspirated design eliminates turbocharger reliability concerns, including heat management, oil supply issues, and boost system complexity. The engine produces adequate power while maintaining mechanical simplicity that promotes long-term durability. Port and direct injection combination provides good fuel delivery without carbon buildup problems associated with direct injection-only systems. The engine management system is relatively straightforward compared to modern turbocharged and hybrid alternatives. The Pentastar's track record across multiple vehicle applications demonstrates its fundamental reliability when not compromised by vehicle-specific design challenges. Applications in sedans, SUVs, and trucks have shown consistent performance across hundreds of thousands of miles. Regular maintenance requirements are straightforward with conventional oil changes, spark plug replacement, and cooling system service. The engine doesn't require specialized tools or procedures that increase maintenance costs. Number 4, Honda Ridgeline 3.5-liter V6, 2020 to 2025. The Honda Ridgeline's 3.5-liter V6 takes number 4, representing Honda's commitment to proven naturally aspirated engine technology. The 2025 Ridgeline earned number 1 ranking in midsize pickups from J.D. Power with an overall score of 82 out of 100. Honda's V6 engine features the company's legendary attention to manufacturing precision and quality control. The naturally aspirated design avoids complexity and potential failure points associated with turbocharging, maintaining mechanical simplicity that has made Honda engines famous for reliability. The engine incorporates Honda's variable cylinder management system, which deactivates cylinders during light load conditions to improve fuel economy. Unlike some cylinder deactivation systems that cause problems, Honda's implementation has proven reliable across multiple applications. Direct injection technology provides efficient fuel delivery and power output, while the naturally aspirated design eliminates turbocharger heat and complexity concerns. The engine produces smooth, linear power delivery, well-suited to daily driving and light truck duties. Honda's reputation for engine reliability stems from conservative engineering approaches that prioritize long-term durability over peak performance figures. The company's engines consistently rank among the most reliable in automotive surveys and owner reports. Some owners have reported minor transmission performance issues, including slow-down shifts and occasional delayed shifting, but these appear related to transmission calibration rather than engine problems. The V6 itself holds up well against newer turbocharged 4-cylinder competitors. Number 3, Nissan Frontier 3.8-liter V6, 2020 to 2025. The Nissan Frontier's 3.8-liter naturally aspirated V6 takes number 3, representing the last bastion of simple, reliable truck engine design. The 2025 Frontier earned number 2 ranking in midsize pickups from J.D. Power with an overall score of 81 out of 100, with 85% of owners recommending the vehicle. The Frontier's V6 stands out in today's market as one of the few remaining naturally aspirated engines in the truck segment. This design philosophy prioritizes proven reliability over cutting-edge technology, appealing to buyers who value long-term durability above maximum efficiency. The naturally aspirated design eliminates turbocharger complexity, heat management issues, and forced induction reliability concerns that plague modern engines. The engine produces adequate power for truck duties while maintaining mechanical simplicity that promotes longevity. Owner testimonials specifically praise the engine's simplicity compared to competition, with buyers expressing hope that the truck will last many years without expensive maintenance or breakdowns. This perspective reflects growing consumer awareness of reliability trade-offs with complex modern powertrains. The 3.8-liter displacement provides good low-end torque for truck applications without requiring forced induction to meet power requirements. The engine's conservative tuning prioritizes durability over peak performance figures that often compromise long-term reliability. The engine features conventional port fuel injection rather than direct injection, avoiding carbon buildup issues that affect many modern engines. The simpler fuel system reduces maintenance requirements and potential failure points compared to complex injection systems. Number 2, Honda Ridgeline 3.5-liter V6 core engine, 2017 to 2025. The Honda Ridgeline's 3.5-liter V6 core engine technology takes number 2 when evaluated across its broader application range beyond just the truck platform. This engine represents Honda's pinnacle of naturally aspirated V6 development, with applications across multiple vehicle lines demonstrating exceptional reliability. Honda's J35 V6 engine family has powered everything from sedans to SUVs to trucks, accumulating millions of miles of real-world data that confirms its fundamental reliability. The engine's track record spans multiple generations of refinement without major design changes that could introduce new failure modes. The engine features Honda's advanced variable timing control system on both intake and exhaust camshafts, providing optimal valve timing across the entire operating range. This technology improves both performance and efficiency without forced induction complexity. Honda's manufacturing quality control sets industry standards for precision and consistency. The company's attention to tolerances, material quality, and assembly procedures creates engines that consistently perform well beyond their design life when properly maintained. The naturally aspirated design philosophy aligns with Honda's conservative engineering approach that prioritizes long-term reliability over headline-grabbing performance figures. This philosophy has created a reputation for engines that routinely exceed 200,000 miles with basic maintenance. Variable cylinder management technology allows the engine to operate on 3 cylinders during light load conditions, improving fuel economy without turbocharging complexity. Honda's implementation has proven more reliable than some competing cylinder deactivation systems. Number 1. Nissan Frontier 3.8-liter V6, the last great naturally aspirated truck engine, 2020 to 2025. And the number 1 most reliable V6 engine is the Nissan Frontier's 3.8-liter naturally aspirated V6 from 2020 to 2025. This engine represents everything that modern automotive engineering has abandoned in pursuit of efficiency regulations, and that's exactly why it's so reliable. The Frontier's V6 stands alone in today's truck market as the only remaining naturally aspirated engine in its class. While competitors have switched to complex turbocharged 4 cylinders and hybrid systems, Nissan has maintained the simple, proven approach that actually works. This engine eliminates every reliability concern associated with modern powertrains. No turbochargers to fail from heat and oil contamination. No complex hybrid systems with battery packs and electric motors. No direct injection carbon buildup. No cylinder deactivation complexity. Just 6 cylinders, conventional port injection, and proven technology. The 3.8-liter displacement provides genuine truck capability without requiring forced induction gimmicks. The engine produces smooth, linear power delivery, from idle to redline with torque characteristics perfectly suited to truck applications in daily driving. Owner testimonials consistently praise the engine's simplicity and reliability expectations. Buyers specifically choose the Frontier because they want proven technology rather than experimental powertrains that serve as beta tests for early adopters. The engine's conservative design and tuning prioritize longevity over peak efficiency numbers. While it may not achieve the EPA ratings of complex turbocharged competitors, it delivers real-world reliability that actually saves money through reduced maintenance and repair costs. Nissan's manufacturing approach for this engine emphasizes proven processes and quality control rather than cutting-edge technology that introduces new failure modes. The result is an engine that performs its intended function without the drama and expense of modern alternatives. The 3.8-liter V6 represents the end of an era in automotive engineering. As regulations force manufacturers toward increasingly complex solutions, the Frontier's engine stands as proof that simple, reliable engineering still works better than complicated efficiency chasing. This engine will likely be remembered as the last great naturally aspirated truck engine, delivering the reliability that truck buyers actually need rather than the complexity that manufacturers think they want. These 13 engines represent the pinnacle of V6 reliability and engineering excellence. Now you need to see the complete opposite. Engines so catastrophically bad, they destroyed entire brands. Check out my breakdown of the 20 worst car engines in automotive history.